In this video, we're going to be going over binary ionic compounds, and this is our part 3 video inside of chemistry, chapter 2. And in our previous video, we talked about binary molecular compounds, so if you're interested, you can also watch that video out as well. But specifically today, we're going to talk about binary ionic compounds. So let's get started with this video. So first of all, let's just do a quick recap of what binary compounds are. So binary compounds are composed of two different elements, and an example is sodium chloride. So sodium chloride is composed of two different elements, and the first one is sodium and the second one is chlorine. And another example can be nitrogen dioxide. So nitrogen dioxide has nitrogen and also oxygen. So that makes it a binary compound. So what is not a binary compound? So compounds that contain more than two elements, such as sodium nitrate. So sodium nitrate contains of three different elements. So first one is sodium, second one is nitrogen, and also oxygen. So this would not be a binary compound. So now what is a binary ionic compound? So binary ionic compounds consist of ions from one metallic and one non-metallic element. And we also learned more about this in chapter 1. So ionic compounds contains of one metal and also one non-metal. So if you have only one metal and one non-metal combining, then those are going to be equal to a binary compound. But if you have multiple, then those are not going to be equal to binary compounds. And also binary ionic compounds, they're joined by ionic bonds. In this case, we're going to take an example of calcium fluoride. So the bond is between calcium ions and also fluoride ions. So inside of calcium fluoride, calcium is the metal and also fluoride is the non-metal. And in this case, calcium has 2 valence electrons, so that means there's 2 electrons in the outer shell, and fluorine has 7. So as we talked more about this in chapter 1, if we have 1 or 2 in the outer shell, we're going to want to give it away because we want to become stable and have a full octet. And since fluorine has 7, it wants to gain 1 so then it can also be stable. So what calcium does here is, since calcium has 2 valence electrons, it combines with 2 different fluorines. So it gives one of its valence electrons to one fluorine atom and then the other one to another fluorine atom. And this is still a binary ionic compound because there's only 2 different elements that's being used. And in this case, once calcium gives those 2 valence electrons to fluorine, then calcium becomes 2+ because it has more protons than electrons. It has 2 more protons compared to the electrons. And then in this case, fluorine will become -1 because it's gaining 1 more electron, so that means it has 1 more electron compared to the amount of protons it has. So this is more about binary compounds. So furthermore, the first element inside of a binary compound is the metal. And in the name and also the formula of the binary ionic compound, the first element listed is the metal. So as we can see in the calcium fluoride, calcium is the metal and fluorine is the non-metal. So the second element is an ion with an IDE suffix. So fluorine is called lithium fluoride or calcium fluoride. So whatever the second element is, it has an IDE suffix inside of the binary ionic compound. So now for the chemical formula ratio. So the formula CaF2 indicates that in calcium fluoride, there are 2 fluoride ions for every 1 calcium ion. And if we look at this picture here, we can see that there is 2 different fluorine ions for every 1 calcium ion. And furthermore, the representation of ionic compounds. So unlike molecular compounds, which consist of discrete molecules, ionic compounds form a crystal lattice structure, and we also talked more about this in our previous videos, so you can also check those videos out if you want to learn more about the crystal lattice structure. And also, binary ionic compounds are not actual molecules. It's just important to note that formula units are not actual molecules and they do not represent a specific number of atoms bonded together in a discrete entity. Instead, they show a ratio of ions in the ionic lattice that makes a solid compound. So this summarizes everything about binary ionic compounds. So now we're going to do some practice problems to see if we understood what binary ionic compounds are. So for the first one, write the name of each of the following ionic compounds. So you might need your periodic table in order to list the elements and to know what the elements are. So feel free to pick that up and also to do all these practice problems by yourself. Okay, now we're going to go into solutions one by one. So Li stands for lithium and Cl stands for chlorine. So we already know that this is an ionic compound, so that means that chloride is going to be an IDE suffix, so this means that we're going to have lithium chloride. So for the next one, for letter B, so K is potassium, Br is bromide, so potassium bromide. So for C, Ca is calcium, and then Cl is chloride, so calcium chloride. And then for the last one, which is letter D, Mg is magnesium, and oxygen, so magnesium oxide. So here's all the answers. So LiCl is lithium chloride, KBr is potassium bromide, CaCl2 is calcium chloride, and MgO is magnesium oxide. So now for practice problems number 2, predict the formula for each of the following ionic compounds. So once again, feel free to pause the video and try this by yourself. So for letter A, we have sodium fluoride. So sodium is Na, and fluoride will just be F. So sodium fluoride is equal to NaF. So for letter B, we have magnesium fluoride, and this will make MgF2. And this is because for every magnesium atom we have, there's going to be 2 different fluorine atoms. And then for letter C, we have barium bromide, which is BaBr2. So the same thing, there's going to be 2 bromide atoms for every barium atom. And for letter D, we have aluminium chloride, so AlCl3. So in this case, there's 3 chlorine atoms for every aluminium atom. And finally, for the last practice problem, write the name of each of the following ionic compounds. So the first one we have is Kf, second one is K2O, for the third one we have CaO, and finally for the last one we have BeF2. So once again, feel free to pause the video, and we're going to get into the solutions now. So for Kf, we have potassium fluoride. For K2O, we have potassium oxide. For CaO, we have calcium oxide. And for BeF2, we have beryllium fluoride. And that summarizes all the practice problems for today. So as a summary for this video, we went over binary ionic compounds and also some practice problems. And in our upcoming content, we're going to talk about cation charges. So that summarizes everything for this video, so thank you so much for watching to try to be useful, and we'll see you guys in our next video.